The Chugach people of southern Alaska's Kenai Peninsula have picked berries for generations. Tart blueberries and sweet, raspberry-like salmon berries, an Alaska favorite, are baked into pies and boiled into jams. But in the summer of 2009, the bushes stayed brown and the berries never came. For 3 more years, harvests failed. It hit the communities very hard, says Nathan Lodgewski, the forestry manager for Chugachmi. The berry bushes had been ravaged by caterpillars of geometric moths, the Bruce spanworm and the autumnal moth. The insects had laid their eggs in the fall, and as soon as the leaf buds began growing in the spring, the eggs hatched and the inchworms nibbled the stalks bare. Chugach elders had no traditional knowledge of an outbreak on this scale in the region, even though the insects were known in Alaska. These berries were incredibly important. There would have been a story, something in the oral history. At the peak of the multi-year outbreak, the caterpillars climbed from the berry bushes into trees. The pests munched through the foliage. In summer, thick brown-grey layers of denuded willows, alders and birches lined the mountainsides above stretches of Sitka spruce. 2 summers ago, almost a decade after the first infestation, the moths returned. We got a few berries, but not as many as we used to. Last year, again, there were hardly any berries, Chugach elder FM. For more than 35 years, satellites circling the Arctic have detected a greening trend in Earth's northernmost landscapes. But recently, satellites have been picking up a decline in tundra greeness in some parts of the Arctic. Those areas appear to be browning. Like the salmon berry harvesters on the Kenai Peninsula, ecologists working on the ground have witnessed browning up close at field sites across the circumpolar Arctic, from Alaska to Greenland to northern Norway and Sweden. Yet the bushes bereft of berries and the tinder dry heaths, low-growing shrubland, haven't always been picked up by the satellites. The low-resolution sensors may have averaged out the mix of dead and living vegetation and failed to detect the browning. FCK. Scientists are left to wonder what is and isn't being detected, and they are concerned about the potential impact of not knowing the extent of the browning. If it becomes widespread, Arctic browning could have far-reaching consequences for people and wildlife, affecting habitat and atmospheric carbon uptake and boosting wildfire risk. Growing greenbelt. The Arctic is warming 2 to 3 times as fast as the rest of the planet, with most of the temperature increase occurring in the winter. An early effect of the warmer climate was a greener Arctic. More than 20 years ago, researchers used data from the National Oceanic and Atmospheric Administration's weather satellites to assess a decade of northern plant growth after a century of warming. The team compared different wavelengths of light, red and near-infrared, reflecting off vegetation to calculate the NDVI, the Normalized Difference Vegetation Index. Higher NDVI values indicate a greener, more productive landscape. In a single decade, from 1981, when the first satellite was launched, to 1991, the northern high latitudes had become about 8% greener, the researchers reported in 1997 in Nature. In new images of the same locations, such as the Kukururok River in the Notak National Preserve, low-lying tundra plants that once grew along the riverside terraces had been replaced by stands of white spruce and green alder shrubs. In 2003, the researchers found that the highest NDVI values, or peak greeness, during the growing season had increased nearly 17% between 1981 and 2001, in line with the warming trend. Earth-observing satellites have been monitoring the Arctic tundra for almost 4 decades. In that time, the North Slope, the Canadian low Arctic tundra and eastern Siberia have become especially green, with thicker and taller tundra vegetation and shrubs expanding northward. Yet parts of the Arctic, including the Yukon-Kuskokwim Delta of western Alaska, the Canadian Arctic Archipelago, the northwestern Siberian tundra, show extensive browning over the length of the satellite record, from the early 1980s to 2016. It could just be a reduction in green vegetation. It doesn't necessarily mean the widespread death of plants. All the models indicated for a long time that we would expect to green with warmer temperatures and higher productivity in the tundra, so long as it wasn't limited in some other way, like by lower moisture, says Scott Goetz. Many of us were quite surprised that the Arctic was suddenly browning. It's something we need to resolve. Freeze-dry tundra. While global warming has propelled widespread trends in tundra greening, extreme winter weather can spur local browning events. In recent years, in some parts of the Arctic, extraordinary warm winter weather, sometimes paired with rainfall, has put tundra vegetation under enormous stress and caused plants to lose freeze resistance, dry up or die, and turn brown. In 2001, in the space of a couple of days, the temperature shot up from 16 degrees C to 6 degrees C, melting the tundra's snow cover. Can you think of the consequences of what will happen if the insulated plants are exposed to the warm surroundings? Arctic plants survive frigid winters thanks to that blanket of snow and physiological changes, known as freeze resistance, that allow plants to freeze without damage. But once the plants awaken in response to physical cues of spring, warmer weather, longer days, and experience bud burst, they lose that ability to withstand frigid conditions. That's fine if spring has truly arrived. But if it's just a winter heat wave and the warm air mass moves on, the plants become vulnerable as temperatures return to seasonal norms. When temporary warm air covers thousands of square kilometers at once, plant damage occurs over large areas. These landscapes can look like someone's gone through with a flamethrower, Phoenix says. It's quite depressing. You're there in the middle of summer, and everything's just brown. Gerald Bjerg, a vegetation ecologist at the Norwegian Institute for Nature Research in Tromsø, saw browning across northern Norway and Sweden in 2008. The landscape, covered in mats of crowberry, an evergreen shrub with bright green sausage-like needles, was instead shades of brown, red-brown and greyish-brown. Bjerg, Phoenix. Other researchers continue to find brown vegetation in the wake of winter warming events. Long periods of mild winter weather have rolled over the Svalbard archipelago, the cluster of islands in the Arctic Ocean between Norway and the North Pole. In the snow melted or blew away, exposing the ground-hugging plants. Some became encrusted in ice following a once unheard of midwinter rainfall. In 2015, the Arctic bell heather, whose small white flowers brighten Arctic ridges and heaths, were brown that summer, grey the next, and then the leaves fell off. It's not new that plants can die during mild winters, Bjerg says. The new thing is that it is now happening several winters in a row. Insect invasion. The weather needn't always be extreme to harm plants in the Arctic. With warmer winters and summers, leaf-eating insects have thrived, defoliating bushes and trees beyond the insect's usual range. Autumnal moth outbreak is a very visual moment, and caterpillars are crawling all over the plants. In northern Sweden during summer. In northernmost Norway, Sweden and Finland in the mid-2000s, successive bursts of geometrid moths defoliated 10,000 square kilometers of mountain birch forest, an area roughly the size of Puerto Rico. The outbreak was one of Europe's most abrupt and large-scale ecosystem disturbances linked to climate change, says Jane Jepsen, an Arctic ecologist at the Norwegian Institute for Nature Research. These moth species benefit from a milder winter, spring and summer climate, Jepsen says. Moth eggs usually die at around 30 degrees C, but warmer winters have allowed more eggs of the native autumnal moth to survive. With warmer springs, the eggs hatch earlier in the year and keep up with the bud burst of the mountain birch trees. Another species, the winter moth, O. brumata, found in southern Norway, Sweden and Finland, expanded northward during the outbreak. The spring and summer warmth favored the larvae, which ate more and grew larger, and the resulting hardier female moths laid more eggs in the fall. Smoldering lands once rare, wildfires may be one of the North's main causes of browning. As grasses, shrubs, trees across the region dry up, they are being set aflame with increasing frequency, with fires covering larger areas and leaving behind dark scars. Sparsely populated places, where lightning is the primary cause of wildfires, are also seeing an uptick in wildfires. Scientists say lightning strikes are becoming more frequent as the planet warms. The number of lightning-sparked fires has risen 2 to 5% per year in Canada's Northwest Territories and Alaska. In 2014, the Northwest Territories had 385 fires, which burned 34,000 square kilometers. The next year, 766 fires torched 20,600 square kilometers of the Alaskan interior, accounting for about half the total area burned in the entire United States in 2015. In the last 2 years, wildfire activity is taking place even in infrequent areas, and within 30 years could quadruple in Alaska by 2100. The loss of wide swaths of plants could have wide-ranging local effects. These plants are the foundation of the terrestrial Arctic food webs. The shriveled landscapes can leave rock ptarmigan, for example, which relies heavily on plants, without enough food to eat in the spring. The bird's predators, such as the Arctic fox, may feel the loss the following year. The effects of browning may be felt beyond the Arctic, which holds about half of the planet's terrestrial carbon. The boost in tundra greening allows the region to store, or sink, more carbon during the growing season. But carbon uptake may slow if browning events continue, as expected in some regions. Trehan, Phoenix, colleagues reported in February in Global Change Biology that on the Lofoten Islands in northern Norway, extreme winter conditions cut in half the heathland's ability to trap carbon dioxide from the atmosphere during the growing season. Yet there's still some uncertainty about how these brown tundra ecosystems might change in the long term. As the land darkens, the surface absorbs more heat and warms up, threatening to thaw the underlying permafrost and accelerate the release of methane and carbon dioxide. Some areas might switch from being carbon sinks to carbon sources. On the other hand, other plant species, with more or less capacity to take up carbon, could continue on their trajectory of greater productivity.